Hey everyone, welcome to the ARW discussion. I'm Billy, and today we're going to be talking about some stuff. We're going to be talking about insert tooling versus high speed steel versus carbide for both end mills and lathe tooling. How many flutes, speeds and feeds, coatings, sharpening them, and various other bits. Let's kick this off. Who wants to go first? Don't make me pick.
No one's volunteering, yeah.
I've got a bunch of tools right in front of me. I can go.
All right, go for it.
Well, first of all, for drills, I pretty much always use high-speed steel. End mills, I'm usually using carbide. And my favorites, I've got a little, yeah, everyone can see that. I've got an indexable 3/4 inch one from Shars. That is my workhorse. This takes APKT inserts.
Oops.
For slightly bigger stuff, I found this one used. It's a single flute, takes a triangular insert. I don't think it even has a brand name on it, but I got it for I think $20 used, and it works great. The insert's cheap. It's just a standard TPG insert. For the lathe, I'm kind of I don't know, maybe 80-20 high-speed steel to carbide. I have a lot of high-speed steel tooling for my lathe still. But the vast majority of my work, I'm using this dude here this is from Mesa Tool. And I've actually got one of their boring bars as well. And I have a threading tool that I didn't bring into my bedroom with me, but pretty decent. I got to get some more of these inserts. Maybe something with a chip breaker if I can find that, because the smooth top is it breaks down quite a lot. And yeah, DJ, you don't want to plunge with these guys at all. I've got a bunch of insert tooling from Shars, and this is actually the threading tool that I use most. It's crap, I can't get it to center up here. It takes the triangular inserts with 3 threading edges, so you can flip that. We use these at work a lot. I've got one for every lathe there. And I've actually got a bunch of their tooling. I've got a turning tool, a facing tool, and a 45 tool and a threading tool for each lathe at work that I got all from Shars. I've got a couple of insert boring bars as well. I started out thinking, oh, I'm going to get stuff and just use all the exact same insert, and that went out the window really fast. My main face mill, I've got a couple of face mills, but this is one that I got off of eBay, and it's a Sandvik. I bought this thing for $50. It takes kind of an oddball square insert with a wiper. There's a slight angle right there on the cutting edge, and you can see it's not a 90-degree face mill, but that's not how I'm usually using it. Leaves a great finish in most materials.
What's the diameter of that one?
I think it's a 3-inch. And then actually Shars sells in the non-indexable stuff here. Shars has a line of US-made carbide, solid carbide end mills that are fantastic, especially for the price. And I'm not being paid to say that or anything. I can get a 1/2-inch 2-flute end mill or 4-flute end mill for $30 or less. We cut a lot of keyways at work, and I have a lot of ham-fisted employees in my shop, so they burn through a lot of emails or end mills. So I don't particularly want to spend $100 on an end mill just to have it ripped up on a keyway. So these dudes are fantastic. I get a lot of mileage out of it myself when I'm careful with them. And I've got ball end mills from them. This is a 3/16 ball end mill that I got from them for the base knobs project that I did a few months ago. And a lot of bang for your buck there. Really fantastic end mills. I think they use Sandvik blanks. and they're really nicely ground, leave a great finish. Way better than a lot of the name brand end mills that I would buy in high speed steel. So that's pretty much all I brought, except I also have this tiny little boring bar as well, 3/8 boring bar, and it's got that 80-degree diamond insert. I can't remember the number on that one, but really handy for tight spots. Yeah, that's about all I've got.
Yeah, so the thing I've got is trying to figure out the, high speed steel versus the inserts for the lathe. Which to go for. In the maker space, I don't have time to teach people how to, and not to mention I don't know how to right now to grind the high speed steel tooling for them. So I just find it easier just to get the inserts. For the milling machine, I absolutely love using 2-flute high-speed steel end mills for aluminum. I don't like the coated kind. For some reason, I had problems way back when with chip welding with the coatings on that stuff. But the high-speed steel seems to do pretty good. And then the rest of the stuff, I like using the carbide for any kind of steel work I'm doing. 3 or 4, 4 or 5 flute end mills that I've got. But to be honest, we don't have a large inventory of end mills. We typically use the cheaper high-speed steel ones from Shars or a little machine shop or something like that. So I'm always looking for advice on how to better educate the makers on what to use for that kind of stuff and what I should be stocking at the space, so if they break something, they can go and replace it or buy it for their use. So that's where I'm coming from on all this.
I have a comment, Billy. So I'm certainly no expert at all, but I really like the roughing, the corn cob end mills. They seem to be more forgiving for novices such as myself. They're not as fussy on feeds and speeds and so forth. And just a general comment. I don't know if anybody else wants to chime in on that or not.
They're just a whole lot rougher surface, right?
Yeah. Sometimes that finish is kind of nice to leave that. It's it's a unique finish that it leaves.
I agree. They are more forgiving.
Yeah, I've had good luck.
You get all the tiny chips instead of the long stringy needles as well that will go right into your fingers.
Yeah. And for that occasion when you accidentally bump your X feed axis a little bit too fast, they tend not to break as much as the regular ones. If you get
Billy, you were talking about chip welding. Aluminum loves to stick to everything pretty much, but they do have zirconium nitride coated end mills. It's like a bright yellow color. Okay. And that's specifically for aluminum. It doesn't want to stick to it for some reason. So you can look into that. Of course, they're a bit more expensive. So in the maker space, I'd probably just go with bright ones.
And you'll still have to use lube with that, or it will stick.
Yeah, we definitely use lube. When I just did a class yesterday, and of course I've got some kerosene mixed with some oil or diesel sitting there that I have them put on the cutter every time. And I also tell them to, when they're doing it on the mill, they just get a whiff of that white smoke coming off there. They're running about the right speed. If it's coming off too heavy, they're pushing it too hard. And if they're not getting any, they're not pushing it hard enough. Just a little bit of wisp of that white smoke coming off from that cutting fluid. I have learned that you can soak those end mills in something like Drano or something like that to eat that aluminum off there. If you do get chip welding, you can bring back one of those end mills. And then inspect the edges and make sure they're still nice and clean.
A note for that: if it's carbide, the Drano will also eat the cobalt binder in the carbide a bit. So careful.
Yeah, just the high-speed steel is all I would use it on. I wouldn't use it on any carbide. I want to point out that Dennis Nolan's on here, and he does quite a bit of this tooling stuff, so I'm paying attention to him today. Dennis, if you're listening to me, keep throwing out comments, okay?
Yeah, Dennis is a great guy.
I want to pick his brain a little bit sometime about some carbide stuff for the makerspace as well.
You mentioned cobalt.
I've got an interesting face mill to show you guys. It's one of my favorites. I don't use it a lot, but
let me get you up here.
Yeah.
There you go.
Yeah. So this one is, I think it's an old timer. I really haven't seen any others like it. So it uses, let me see if I can get it here so you guys can see. It uses just a plain Jane square type insert. And you can see, you can adjust the depth on the individual cutters and get around here. So you can set the depth. And this thing is very solid, and it just leaves just a beautiful finish. I need to rotate the inserts, but it's a 2-inch, and it just has a 3/4 shank on it. But man, I love this thing. It just does a great job, and it came with the mill, so I have no idea who sells it. There's no maker's mark or anything like that on it. But
so you can actually dial in each insert's height.
Yeah, exactly. Yeah,
that's kind of rare. I hadn't seen that before.
Yeah, and I think it's because it's old school. Yeah, it's just definitely different. I got one other one here, and I've never used this one. This is another one that came with my mill. I took one of them out, but the inserts, they're almost like a standard brazed carbide style insert, and you can see that they've got a little slotted screw down here. So you same thing, you have to adjust the depth of each one. And I haven't tried this yet, and I'm not sure if you can do this on just a regular carbide grinder, but you can resharpen them, regrind them. So I need to find some time to experiment with this thing, but it's pretty interesting. And it's about a 3-inch diameter, and it's got a regular R8 on it. Yeah. So, and once again, it came with my mill. There's no maker's mark or anything like that. But what I did notice is all the fasteners are they're all metric. So it might be an early import of some sort.
Fairly interesting.
Yeah.
I wonder if you could take a brazed carbide tool or 6 of them and actually mill slots in them and drill holes in them and put them in there. Replace those.
They do have a little bit of an offset. They're not perfectly straight. I don't know if you can see that or not. But I don't know if that's a requirement or if that's just the way that these happen to be.
Yeah.
I've got one that's just clamps those in, and on the square insert, this one came with one of my machines too, which I haven't really gotten to clean up and use. But that also has the clamp and the raise up of the square. This one does have some marks on it. It says it's an LTC. I got a couple odd numbers in there I can put in the comments if you guys want. But same concept with the square and the bolt to raise it up and down.
Yeah, it's just like the small one. Yeah, interesting.
Yeah. This one's an R8.
It's funny. I see these big 3-inch face mills. I was reading in the manual just this afternoon on the Bridgeport 1.5 horsepower. They say max face mill is about 2-inch.
Oh, ignore that.
You can fudge that. So if you get a positive rake insert, it takes a lot less power from the motor to drive those inserts. So most inserts are like this here, sort of negative rake or neutral rake. You can buy these aluminum cutting style. Let's see if I got that there. That's a positive rake insert. It'll even take a negative rake holder and make it positive. And they're also very sharp and polished, as you can see in the light. And so they take a lot less power to drive, even through steel. They're not supposed to be for steel, but in a pinch, I've used them, and they seem to work all right. The edge just doesn't hold up as well.
You see a lot the inserts for aluminium used on steel. They leave a really nice finish.
Yeah.
That's one thing I need to pick up is some inserts for the aluminum for the tool holders for the lathe. I've been using just regular carbide for aluminum, but we do a lot of aluminum with the space. It's just easier for the guys to work. They're not doing anything that most stuff they're doing doesn't require steel or anything like that. I do want to smack a couple of them upside the head though, because they think they can get in there and do stainless. And I don't know how many end mills I've went through on the Bridgeport where they're using these cheap end mills, and they'll just burn them up on stainless. I don't know what to do on that.
Stainless is abrasive, very abrasive.
I mean, one of these guys got one so hot that it ended up transferring the heat into the collet and turned the face of the collet a different color.
Wow.
Yeah, I was not happy about that.
No, I can understand.
Dennis says something here. Rake is key.
I got a reply on that one. I want to show you a couple of mistakes that I bought.
All right, let me get you back up here. There you go.
So, early on, I was, anytime I saw bargains on eBay, I would pick up, tooling as I could. And this one here, as you can see, it's got a negative rake to it. Okay. And it will work on my machine, but boy, you really got to fight it. It takes a lot of pressure, and it just does not work out that well. And I've got another one, same deal.
Yeah, they're for a high power machine.
Yeah, and they luckily they didn't cost much. They were used on eBay, but I've got a South Bend Heavy 10, and it's just doesn't have the rigidity or the power to handle this type of an insert or type of tool.
I picked up one of those tool holders that Chuck was touting a couple months back that he got from Banggood that can use the same inserts, and you can use all four cutting edges depending on which tool holder you're using. Got them in, and I realized they're really negative rake, and my machine's pretty rigid. It's a 1340, but I still had a hard time with them, so I don't like them near as much as the littler ones that I picked up from Char's.
I have a lot of insert tooling. I think it's really hard to grind the geometry into a high-speed steel like you would get with an insert. But
you don't need.
I do use high-speed steel for form cutting. I guess that's what you call it. I grind my own for a particular form. I didn't grind that. I had that one. I got a friend with an EDM, wire EDM. He cut that for me. Cut a form in brass.
That's really cool.
That's pretty elaborate. Cool.
Yeah.
I use that one for making grooves in a pulley. Let me see if I can share the screen here, Billy.
All right, go ahead.
Can you see it?
Not yet.
We see you.
Yeah, I've got a little thing that pops up on my screen when he shares it. You gotta select it and click OK or something.
You see it?
Mm-mm.
No. I click share.
You click share, and then you got to do share screen, and you select your screen and hit share again. There it is. All right, hold on. There we go.
All right.
Oh.
Good deal. Now this is just a snapshot, so I can't pick them up and rotate them and show them to you. But this is the variety I use. The one on the left I use mostly just for boring. It'll go through a little less than a half-inch hole. That DCMT is a excellent insert, I think, and it works in all four of those tools. To get in wherever you need it. And then that GTN3, I get a lot of people commenting, why are you using your cutoff tool laterally? But that GTN3 is meant to cut laterally and in. And it's really good for like opening up a slot between shoulders. And I got that in the 3 and the 2. That's one of my favorite inserts. And then that BNMP, somebody gave me a handful of those inserts, and I made the holder for it. But that particular insert has a really fairly extreme back rake, which you don't see very often in carbide. So it's very sharp, and that's one of my favorite for hogging off a lot of steel. But probably the one I use the most, that DCMT. Okay, I stopped sharing that.
All right.
That's a good point, Mark. To try to reuse the same insert in different holders, so you're not having to stock, a variety of different types.
Yeah, they're kind of a fragile insert, but if you don't get crazy with them, you can really hog off some steel with them. And they break chips really well. My lathe is a little underpowered for them, but if I really push it, it breaks chips really nicely.
That's what I try to do. I use, I will try to get it closer, these triangular inserts. And I have only this shape. So I have different homemade tool holders. This is one with a little piece of leather. I use it for the shaper, and it breaks every time, so it doesn't work very well. And this same idea for the lathe. This is a boring bar. Now for smaller holes, of course, it doesn't work, and that's where I use high-speed steel. So these are small boring bars. Here's a very long one, of course. On this length, it's not really rigid. I don't know if it wanna show a bit.
Yeah,
this is a little slice of high-speed steel that I weld on a piece of black bar. This is 10 millimeter hot rolled steel. That's all. This is the same. I thinned it a bit, and then just a little piece welded on, and then you can grind whatever shape you want in it. I have a other homemade thing here in high-speed steel, and I can put it in, of course, in whatever direction I want, if it wants to fit. Is the bolt? Oh no, here we go. So if I have enough stick out, I can make the inner corner inside shoulder. If I have a piece that I have to make, like for example, a back plate for my chuck, of course the cross slide of my lathe cannot go backwards enough to cut the side, and then I put this one in on the back side, and it works like a charm. It's high-speed steel, so you can do whatever you want with it. You cut, for example, a piece that's welded, the weld will be gone, and then of course a high-speed steel too, regrind it up, and you're good to go again. And the more you grind high-speed steel tools, the better you get at it. And what the difference with the inserts, I can't show you here, but high-speed steel makes a very nice and sharp corner, cutting edge, and the insert doesn't, is a little bit rounded, which means it's gonna push in a little bit of the material. Most of it will cut, but this very tiny little radius that's left here is gonna push in the material back in place, and that's one of the main reasons why you need lots of cutting forces, lots of power from the motor. And that's also the nice finish, because you can have a fantastic finish on a cylindrical part if you pass it after with a ball bearing, and you push the material back in place and it gives a mirror finish. Again, needs lots of power for the lathe. For my shaper, I always use almost always high-speed steel, and directly in the tool hole. And sometimes I use this one, which goes like this in the shaper, of course. And then I'm gonna take the same little piece here that's too short. I try to watch same time what I'm doing on camera and in real life. So bear with me. I'm amateur, you know. And this one slides in here, and I can put whatever angle I want. High-speed steel, very handy. I have the, how you call it? I forgot the name now. For a brooch for the shaper. And all this junk here is all homemade, except of course the end mill. But I'm an absolute beginner, so I have no idea for my machine if this is a big or a small end mill. I don't know. The last time I used an end mill milling machine was in school. That's about 40 years ago, and this afternoon also. That's all. So for my machine, I don't know. I would like to make a fly cutter, but I don't know the limits of my machine, the maximum diameter I can use. So there's lots of experimenting that has to come up for the milling machine. But for the shaper and the lathe, I use mostly the same tools, and it works really fine. So high-speed steel, the way to go. Especially if you want to try something out you never did before. You have some mysterious material, you don't know what it is. Maybe there's hard spots in it. High-speed steel, if it breaks, no problem, regrind, and you go for it. And if you buy the Amazon inserts, that's a waste of money. So I think if you buy inserts, it's a good idea because they work really fine. But don't be afraid to spend a bit more money to have quality, to have good work, and not these cheap things that doesn't work. I have 3 boxes of this TNMC, I think, inserts, and all 3 of them has a different price and a different quality. And when you take them in your hand, when you use them, they're exactly the same. So I don't know which one are the cheap and which are the expensive ones. Don't know. So I like more to buy my things. I don't have them here on how to say well known over here. I like to use products of Phantom. I'm not sponsored by Phantom, but they have amazing stuff. The cutting fluid, the coolant I use is from Phantom. It costs you a fortune, okay, but you can use it for everything. I reuse the old coolant from my lathe that becomes dirty and stinks. I put it in a can, and I use it in my little pump brush, you see, and I use that for aluminium, for tapping, for the lathe, for everything, and it works great. Okay, next one.
Okay,
All right.
let me say
Rusty,
something if I can.
Go
that
ahead.
okay? I mean, I'm a bit like Michelle there. I mean, I did machining when I was kind of 16 or 17, and then I didn't do anything for 40 years, and I bought myself the lathe you might have seen on my channel. So I'd not used inserts ever before, and so I've kind of built up the insert holders that you've seen there from Stuart and Mark, very similar. And what I've generally done is bought the cheapest inserts that I can, mainly because, inserts can be expensive and I don't know what I'm doing. So I get along with them reasonably well. I managed to get a couple that were Sandvik inserts, and they're definitely better. So I generally agree with the view that if you pay a bit more, you get more, you get a better insert. I know that I nearly always run my machine too slow, my lathe too slow. And, I get comments on my channel, why are you running so slowly with those carbide inserts? But I guess, having learnt on high-speed steel, I know the theory that I should be running my machine faster, but I'm going to have to really work at it to get myself to do it. The time I use high-speed steel cutting tools on the lathe is if I'm working with anything that's got a kind of glaze on it or likely to glaze. So I can think of cast iron as an example, where I want to get a really nice clean face, maybe not a very deep cut, and with the sharp high-speed steel tools I can do that. If I try and do that with carbide, it just burnishes the surface of the cast iron. So I think that's probably my input. I haven't tried any carbide tools on my shaper, Michelle, and I don't plan to do that.
But if you want to try, no problem. But take the cheap ones from Amazon or eBay, and then if you break one, it's broken. No problem. It's not really a waste of money. I think it's a good idea to test something you never did before. If you never used inserts, okay. I did too. I have some Amazon sheet over here. And it's nice to try something. If you don't really know, go for it. Oh, it breaks. Okay.
Well, I just watch your channel. I don't need to break any inserts. I can see.
That's why I share this YouTube thing. So if I do stupid things, you don't have to copy. It's stupid.
I learned something.
And if you copy, you are stupid. So
I don't know if you guys
I don't mean it, okay? It's just
yeah. It's okay.
Experimenting is fun, and copy and experiment. I think it's even double fun. And break the same thing. Why not? Just don't break the machine, because that's not fun. And that's why I, like you, Paul, I don't like to push my old little machines, because I have small machines. I cannot make A-bomb ships. It's not possible. And I don't even try. If you a machine, when you work with it and you use it, you feel it. A machine is talking to you. Sounds crazy, but every machinist gonna tell you the same thing, or can approve what I'm telling you here. And the machine is telling you, okay, this is it. Now we're running fine. And don't push more, because you're going to wear the machine way too quickly. And I see some really beautiful old lathes, for example, on YouTube. That's a beautiful machine. And then they push it with these inserts. I'm not a fan. I don't think these old machines are designed to have these heavy loads. Okay, I'm talking too much. Go for it, Billy.
We're enjoying it.
Let's give Dylan a chance to speak here, guys. Which one of y'all want to talk?
Michelle, I think I don't think I've got a lot of turning on my channel at the moment, but you would hate me. I've got an old Sheldon.
I don't hate anyone. Don't worry.
The Sheldon behind me. That's it's a beautiful old a wartime machine, and I've shot the bearings on that, man. It's gone. Mostly using insert tooling. So when I bought my first lathe, the first thing I did was bought a load of brazed carbide, and I didn't have that long enough to try it out. I gave that away with it and bought a Myford, and then moved up to the Sheldon. And I've tried grinding HSS, and I'm kind of with Paul here, which is like buy the cheap inserts and just burn through them, because 90% of the time it doesn't matter. And if you have something special in mind, so when I'm turning threads, I'll spend the money. I'll go and spend £5-10 an insert. But for the most part, just bang in 30-40 pence inserts and you're done. And it's the same for the stuff that I make. So I make scrapers and scraper inserts. To make a land on a scraper, you don't need to spend big money. Someone mentioned the aluminium inserts for the face mills earlier, and I discovered that very much by accident. The aluminium inserts leave a great finish. So I bought a countersink, a carbide insert countersink, and it came with the wrong size inserts. And they were these little silver aluminium things, and they were great on steel. So face milling, flats and stuff, they're great. Again, they're so cheap, it doesn't matter. And if I've got something special in mind, the APKCs go into the face mill, and they're more expensive, but they're worth it if it's a proper project. Otherwise, for production work, cheap, burn through them, get it done. Don't worry about it too much. Or for anything that isn't decorative, or it's going to be seen. So there's that. But now I've kind of lost my thread and forgotten where I was going with this. But if you're cheap inserts, get on AliExpress or eBay and just buy a load of cheap stuff and break it. That's kind of it. Oh, actually, no, that's where I was going. So we're talking about grinding HSS. Now, I'm terrible at grinding HSS, but I just bought, feeling that way, this thing behind me, this grinder here, kind of point there, has a nice chart on the side. And originally it would have come with some really nice tooling for grinding on the wheels. And it comes with a chart on the side, which gives you rake angles, gives you the chip breaker angles, and if you've got the right tooling on there, how to cut them on the machine. So even just downloading something like that, sticking up above your grinder would be, I guess would help. I'm going to find out when we get the thing running. So and see if I can get into grinding HSS, which I generally avoid because it takes more time, especially if it's production work. It takes more time, and it's more of a hassle. So for me, inserts rule, and I will get into HSS one day.
Most of my high-speed grinding has just been touching up tool bits that I've already picked up from various machine shop sales and so forth. I just keep copying the same grind, just keep moving it down a little further.
Yeah. I mean, you want to have a go with this?
I don't think you can get the same profiles in high-speed steel. I do think there's a place for high-speed steel, but the inserts have a big advantage to being able to mold a profile for breaking chips. And obviously, they're not as sharp, and they do require more power. But like this one here, I don't know if you can see that or not.
It's got a really
that
break on it.
Yeah, I do for soft materials.
It works great for removing a lot of stock, and it's fairly sharp. But they don't make it anymore, so I get them used on eBay. I don't know why they don't make them. Probably because they don't hold up in industrial situations because they've got too sharp an edge.
On eBay have really started to dry up. There's not a lot of them available like there used to be.
Yeah.
Could be.
It's hard to find that one.
Why do you think that is, Dean?
Maybe it's a supply chain issue. Everybody's snapping them up as they become available. It used to be you could find hundreds of inserts available, and I was just looking last week, and I was looking for a specific insert, but boy, there was very few to choose from, and I never did find one that matched up with what I was looking for.
Well, let me interrupt here. We got two other folks that haven't really talked much. We got Dylan and Robert with Dudley Toolright. Do you all have anything to pitch in here on this?
Yeah, I got a couple things.
All right, who wants to go first?
Go for it, Dylan.
All right.
So, I do a whole bunch of mix of different stuff, and I use a little bit of everything for what I do. In my lathes, I use everything from I got a big American Tool Works, which I use for long stuff, and I even have some brazed cut inserts like this guy, which
holy moly!
it's fun to hog metal with it.
Are you showing off?
But usually I'm using more stuff like this sort of size. I use a fair amount of brazed carbide, and then when I do my line boring, I'm going with these micro 100s. They seem to take the beating that I give them a little bit better. I just sharpen them on a regular green wheel, and medium grit takes them pretty well, and a fine grit will give you a nice finish. But when I'm line boring, I do weld up the bores, so it's kind of lumpy in there. And I went to the fancier grade just because it seems to, they don't break quite as much. I still do have trouble on some of the welded ends, and I'll occasionally use some high-speed steel just to have something that doesn't cost as much when it breaks. Or with the weld bead, occasionally I'll even take a little grinder and just take a little lump off first. It's not really great, but it works. I do use some inserts. These are kind of metals. And like this is one of my threading tools. And this thing works pretty darn nice. It's fairly flat on there. Then this guy, this takes a kind of trapezoidal insert. And this guy works pretty well for just hogging off metal, getting into places. I have a limited selection of these, so I can't really get into every place I try to cut with those. I do a lot of hydraulics work, so it's mostly threading and making glands and cylinders. I have had good luck with the high-speed steel for turning out thread profiles. You can really make a nice shaped cutter out of it if I don't have something pre-made. But yeah, it's kind of a mix. It depends what I'm doing, and I have a limited stock of stuff. I have been getting on the end mill side of things into these carbides a little bit more. Place I'm working right now lets me grab a few of the used ones, and I've had pretty good luck looking for ones that have a chip down here or something. I can still use them for other purposes if you look for them. So I'm starting to experiment with carbides. In the past, I've just kind of used the cheap stuff I found. But it's a bit of a mix on everything. I do use the brazed carbide for probably the majority of the line boring and lathe work I do, though. Whether it's the right way to do it or not, it does work, though. So that's probably about all the stuff I got sitting on my bench here with me at the moment. But mix old stuff I got usually.
Dylan, I have a little question, if you don't mind.
Yep.
For when you gonna bore or line bore the welded part, what kind of tool is the best for your use?
I've been using these micro 100s. They're just a brazed carbide, but it's a super fine grade of carbide. I do use a bore welder, so it's a fairly smooth weld. I try to keep it pretty clean. If there's noticeable slag or other junk in there, I'll try to get at it with some wire brush or something to try to clean up any impurities I can. But this will go through a basic MIG weld.
I always use the MIG welder, and if you have a small part but a big weld, there's lots of heat that goes in the part that drains out, and the weld is less hard than if you have a big chunk of steel and you have to put a little weld on it. When you weld just a little spot, it cools so quickly that it's self-hardened, sort of. And that's a real pain to cut off. So if you have a nice big weld, lots of heat, you can cut it off with whatever tool you want, no problem. Small welds always have problems. The high-speed steel is not happy with it because it's not hard enough. And of course, the carbide is so brittle that it breaks. Always have problems to turn off, or in the shaper also. In the shaper works better, but in the lathe, turning off welded parts is not always easy.
Yeah, I do run into problems with the bore welding. Sometimes it will get a hard spot and kind of blows these cutters apart sometimes. And the only thing I've really found for that, I've been taking some coolant and just a regular spray bottle like you use for household cleaner.
Hmm.
I've been soaking it in there with that, and I'll just take a heavier cut if it's breaking them off, try to get down under the hard stuff, and it seems to be the only thing that works. If you take the light cut, it just...
No. What I did a few times that works really well, but of course in your job I see it's not possible. If I have to weld a flange, for example, on this axle here, yeah, and then do some turning work on it, it's too hard. But I like my fire, my blacksmithing fire, my coal fire. I put my part in the fire and then let it cool slowly, and then it's all softened and all stresses are out, and then I can do my turning operations no problem. But I can understand that's a bit complicated with hydraulic cylinders and other parts. But that's maybe a tip for the hobby people. If you have problems, just like me, cutting off welds, if you have a chance, soften, then tempering in an oven or in a fire or whatever, it works well. Of course, if you have to weld a high precision part on something and it needs to stay high precision, it's not a good idea to do this. Yeah, first you put it in the fire, let it cool down, and then you do all the precision turning, because there will be movement, there will be flexion.
All right, let's give Robert here a chance to go.
Yeah.
Okay. So some generic thoughts. If you wonder what the carbide looks like in your carbide tool pit, picture a bunch of ball bearings where most of the ball bearings are tungsten carbide or some other variety of carbide, with a few of them being a binder like cobalt, and then they heat it all together and they sort of melt, the little spheres melt together. So you've got a lot of voids in there at a microscopic scale. The variations in types of carbide are the more binder or less binder, essentially. And so the more binder you have, the more impact resistant it is, I believe. And the less binder, the harder it is, because you have more carbide. So if you're cutting really hard stuff, like you're turning really hard materials, but not interrupted cuts, then you probably want to go for the harder grade of carbide. But if you're doing a lot of cuts where there's a lot high impact, then you want to switch to the higher binder, softer, and that's relatively softer carbide that'll take the impacts better and won't break. As far as cutter shape is concerned, there's sort of three criteria between the range of shapes. So when I started, it was like overwhelming quantity of different cutter shapes, and I didn't know where to go. So I just started buying some at random and playing with them. The first criteria is strength. So when you go from a round insert like this is the strongest insert. And then you go all the way to the other side of the pointy one, like this DCMT. This one's a really sharp one, and it's not as strong. The next criteria is the number of faces you get with the carbide to actually use the cutter faces. So like round, I can just increment this slightly each time it gets dull, and I can get away with a whole bunch of changes, as opposed to this one. It has two cutting faces, and that's it, because it's a very positive rake insert. So the bottom's flat, so you can't flip it over. They do make some like that, like this one, that's actually 6 faces, which was the other part of getting to, is number of edges gives you more cutting edges. So this is 6 total. Squares are 4 total. The round is sort of infinite. So number of cutting edges. And then there's also strength and machine power. So as you can imagine, the round cutting inserts have a lot of interface with the material, because it's sort of a shallow area where it's making contact, versus a very sharp one. So a lot less cutting force, a lot higher cutting force. Personally, I use carbide almost exclusively. That doesn't mean it's better. It's just what I sort of started with. I did have the problem everyone else has with taking too small the cuts with carbide, and since most of the inserts aren't as sharp, there are a few that are, like this one's razor sharp. This one will cut you. As you can see, well, maybe you can't see. It's extremely shiny and about nearly as sharp as high-speed steel, not quite. I tend to use, I tend to take too small a depth of cuts and don't push them quite hard enough so they don't perform as well as they could. I get a lot of comments on that, and over the years, I've sort of pushed them more and more. But when I was taking classes, the teacher always said, "Hey, ease up," probably to preserve their tooling at the school. So, I mean, that's sort of my generic take. I use drill bits. I use high-speed steel, but I have some carbide tool drill bits for those occasions when I got to get into hard materials. Recently, I needed to enlarge some holes in some armor plate for a friend, and high-speed steel just disintegrated into the armor plate. Even the carbide really struggled to get through it. Sometimes I use carbide to try and remove taps. However, it tends to be so brittle that most of the time I end up breaking the drill bit in the tap. It starts cutting, and then it catches on a burr, and then it's gone. That's sort of my 2 cents.
Thank you.
Yeah, well, I'm glad somebody else has some problems with speed and depth of cut. I thought it was just me being a good total novice, but it's reassuring.
How many of you guys use annular cutters?
I've used 1 or 2. I really like them, but we don't have them right now.
Yeah, I have a not a large collection, but I've got a handful of them, and wow, for for punching a large hole, when you don't want to go through multiple steps of pilot, drill, and stepping up in size, wow, they are great. It takes a pretty rigid machine to run them. If you got a milling machine, will do it no problem. They probably wouldn't work too well on a regular drill press, but.
So can I just ask, when you say annular cutter, I'm not quite sure what you mean. Do you mean like a trepanning tool?
Like a slugger. It's where you see them most is in a magnet.
We got one
drills.
coming. We got one coming.
There we go.
Okay.
Oh yeah. I know what you mean now. Yeah. Yes. Okay, I know what they are.
They leave a very clean hole, and they don't require a lot of power, but you do need a rigid machine to run them.
Yes.
I've used, believe it or not, just straight up high-speed steel profile to go through.
I've done that a bunch.
Yeah, I do. I've done that in 3/8" steel, and I've done that in about a 1/2 inch thick piece of cast iron for enlarging the hole. Problem I had with that is there was already a hole there that was bigger than the pilot drill bit. So I had to bore out. I think I may have used wood or aluminum and drill a hole through it, and then I clamped it to make a guide for it to go through that cast iron. I was enlarging the hole in my bench top mill for the ball nut to poke through, so I can increase the travel on it. So I had to take it up to about an inch diameter. And that was the best way. I had to do that on the drill press too. The casting was too large to put on the bridge port, and I didn't have a riser block on it, so I had to do that on the regular drill press. That was kind of hairy.
Yeah, I know those as a rotor broach, probably.
Yeah. It goes by quite a few different names. Yeah.
Right. I work with a bunch of iron workers, and they call them Haugen bits all the time. It's a brand name. So they only know them as Haugen bits, and I was asked if I could use an annular cutter for something, and they looked at me like I was stupid. But I have an annular cutter adapter, actually, that I bought off of Amazon. It's an R8 shank, and it's got a spring in it, so they have a little plunger pin that goes into the cutter to eject the slug after it comes out. And it's fantastic. I will never, ever use a hole saw ever again, because you actually get a relatively clean hole. You can do a partial circle as well. They're fantastic. Dylan's got toys.
Yeah, Dylan's got a nice touch there.
No, I was saying that the Haugen bits, I mean, that's what they're using them in. And they got the little ejector on there. But I use this mostly for truck frames or structural or big stuff. But the stuff I drill with them, I mean, I don't think I could push a regular drill bit in the 2 inch or something with this thing. But you can cut it with one of these cutters pretty nice.
So Dylan,
Robert,
is that
did we do a
for the
review on
magnetic
one of
base?
those? Another one of those mag drills like that earlier on?
What's that?
I was asking Robert if he did a review on one of those.
I did.
Mag drills.
Yeah, I did. It's a really inexpensive one. It's kind of cheesy. If you don't have to use it a lot, it's probably fine. If you're using it every day, I would not recommend it.
Milwaukee actually puts out a battery-operated mag drill now. The magnet's still on a cord, but it takes the 18-volt battery, and of course they make something of everything. I mean, there's a battery-operated demo saw and jackhammer now, and all sorts of stuff. So the mag drill's pretty cool.
I mean, keep your eyes open. That one I showed you, I got with probably 20 cutters, and I paid $300 from a guy retiring. They pop up. It's not very often, but they do show up if you want one.
Yeah. Paul, you were talking about Paul and was it Dean that said about depths of cut, and no, it was Robert talking about feed rates and depths of cut. I teach at my local community college, and with high speed steel, we use that all the time for the lathes. I don't want to use carbide with them because they're going to be basically maxing out the speed on the lathe, which then also maxes out the feed rate and makes it more likely for them to crash. So I want to give them as much reaction time as possible. But when they do use carbide, and when people seem to have problems with carbide on YouTube, it's always because they're taking too little of a cut. I mean, I do a lot of 1045 turned ground and polished at work, and the minimum depth of cut, actual depth of cut, is a 50 thousandths. If you take less than that, the surface just ends up looking smeared and torn. But if you get a fair enough bite, then you'll actually shear off the material. You'll see the chip breaking, and you can get a really nice finish, especially in things like 4140. But you've got to take the bite. And of course, to do that, you've got to have a fair amount of horsepower.
Yep, that's the biggest problem I have with mine.
Yeah.
I've
My
definitely noticed
lathe at
that.
home is horse and a half, and it just doesn't have enough, doesn't have the beans to do it, you know. So,
Yeah, 4140, I've had the same problem with. It's sort of like cold rolled. It's really hard to get a good finish unless you take a nice big cut and go fast.
yeah. Yeah, I mean,
I'm always jealous when I see those finishes that A-Bomb's getting.
This cutter right here does pretty good with minimal horsepower. It's pretty small. DCMT.
Yeah.
There you
And
go.
I get a half horsepower, and I have to push it to get it to break chips and get a good finish.
I think that's the same one that I've got, Mark. This is probably the one I use 90% of the time for carbide. And
no, that's different. That looks like a good insert.
Okay. Yeah, this one's is very sharp, and it's only good for soft materials. But you can also get a more blunt insert that'll handle the harder materials. But
Right, is that meant for aluminum?
yeah, this is aluminum. It will do it'll do mild steel. You just got to be careful.
Yeah.
Generally, one of the things I noticed is that I lost my train of thought. Where was I going? Oh, the insert chip breaker shape. One of the reasons there's so many damn inserts is that there's specific chip breakers for every type of material. And clearly as a hobbyist, you don't have them all. And so one trick I found is if I'm not breaking chips, which I'm usually not, higher feed rate starts breaking chips. And then you get a nice finish, but you end up with a spiral pattern. So then if you go with a larger nose radius, you can get rid of the spiral pattern it's leaving, and you get a nice clean finish, but that takes a lot of horsepower. Even mine's 5 horsepower, and I've bogged it down.
Yeah.
Dylan, real quick, have you ever thought about cutting a dovetail into one of those huge brazed carbide things and just sticking it right on your tool post?
You're muted, Dylan.
I only have a couple of these giant ones. I got these with my big lathes. They're more amusing than anything else, but they do take a good heavy cut. I do have some dovetail cutters or holders that I do use on the lathe, which is easier.
Yeah.
That would be a good little project on this thing. Put a dovetail right in it. I think that's.
I've got a couple of big insert cutters that someone gave me, and 1.5-inch shanks, I think. I've been thinking about doing that, cutting a dovetail into them, but I think the center height would be all wrong.
Yeah, I've got one right here that's just waiting for that process.
Yeah.
All right, guys, that's our hour. We're going to wrap this up. I want to remind everyone that next Saturday, not Sunday, next Saturday, we're going to be having a group on from Australia at a different time. I'll be posting that up pretty soon. Give them folks a chance to be on their Sunday instead of on Monday, and we'll have a group of them on. So stay tuned for that. Till then, see y'all later.
Lovely. Yeah, great.
Bye, everyone.
Thanks for coming by.
And thanks for the visit.
Yeah.